Hello and welcome to our lesson. My name is Themba Ncube. Today we are looking at revising of acids and bases. We want to look at the different techniques in terms of answering questions that are based on acids and bases. Right. Now, let's look at the overview of acids and bases as a component of the broader knowledge area of chemical change. So definitely we will look at the different types of reactions involved in as far as acids and bases are concerned. But more importantly, we would also look at the theories that have to do with acids and bases, which is your Arrhenius Theory, your Bronsted-Lowry. We'll also look at different techniques that have to do with acid-base reactions. But also remember that the quantitative aspects, or the stoichiometry that comes to the types of reaction is something that we also need to try and sharpen up. Now, without any waste of time, let's look at some of the key concepts around acids and bases. So we've identified the two broader theories that have got to do with acids. So if you look at an acid or a base, you can describe an acid or a base based on one of the two theories. One of them is the Arrhenius Theory that says to us that because these reactions of acids and bases are actually in aqueous solutions. So Arrhenius says, an acid is by definition a substance that produces hydronium ions in solution, while a base is a substance that produces the hydroxide ion also in solution. The second theory of bases that we must remember, which is very, very important, is the Bronsted-Lowry or the Lowry-Bronsted theory. What does it say? It defines an acid as a proton donor, right? And then a proton is your hydrogen ion, in a solution, but also a base is a proton acceptor. So these are the two theories that are very, very important. What else? We also want to talk about, remind ourselves also of something that relates to the strength of the acid. There's a big difference between strength and concentration. So when you talk about strength of a substance, be it an acid or base, it has to do with the extent at which it dissociates. Okay. Now weaker acids, they dissociate partially, while stronger acids they dissociate completely in solution. So these reactions actually occur in solution, right? So the pH value, right, which is the pH scale from 0 to 14 of an acid is an indication of its strength, right? So an acid with a pH value closer to 0 is stronger, is that of a stronger acid, while that is closer to 7 but less than 7 is a weaker acid. And then the extent of ionization determines again the strength of the acid, as we have indicated. But also strong acids, they ionize completely, while weak acids, they ionize partially. So that's how we classify acids with respect to their strength. Right. Now let's look at the strength of a base. So the pH value of a base is an indication of its strength. So pH value closer to 14, strong base. pH value closer to but greater than 7, weak base. Right. This is per the pH scale. And then the extent of dissociation. Okay. Now this brings us to another very important point. Bases, they dissociate, while acids, they ionize. That's very, very critical in terms of describing the strength of these acids and bases. Right. And then also we are saying that the extent of dissociation of a base is an indication of its strength. Strong bases, there is complete dissociation, while weak base, there is partial dissociation. Very, very key. Right. Now let's look at typical exam problems, but multiple choice is a very, very important type of a question that we need to familiarize ourselves with, and also try and adopt the necessary skills in terms of the approach to responding to questions of this nature. Right. So pay careful attention to some of the techniques that we will make particular reference to, so that you can also try and use that, so that you practice and become more comfortable in as far as responding to multiple choice problems. Right. So the first question says, consider a redox reaction we're going to underline the key words. So the word redox suggests that this is a type of reaction which involves the transfer of a proton based on a particular theory, okay? So we've got ammonia plus X. X is unknown, and then we get the ammonium ion plus the hydroxide ion. So they're saying here, in the above reaction, X represents what? Right, so we need to look at the products, okay, and then make and say, okay, if we've got ammonia, what could be X if we are to get an ammonium ion? So X actually gives a hydrogen ion, okay, or a proton to ammonia. So a substance that is a proton donor becomes an acid. So anything that has to do with a base is out. So we're going to eliminate the destructors. So anything that has got to do with the base, we eliminate. So we're left with two possible options, okay? So it says water can act as an acid, okay, because it is actually donating protons. So if we say H2O, we are happy to say that if X is a proton donor, it results in the hydroxide ion after donating the proton. So it gives us option A, okay, as the correct answer. Right. Now let's go to the next one. It says, consider the equation below. We've got carbonic acid plus water to give us a hydrogen carbonate ion plus a hydronium ion. Okay, so Bronsted-Lowry bases. So the theory here is about Bronsted-Lowry. Okay, an acid is a proton donor, a base is a proton acceptor, which is some of the concepts that we try to remind ourselves of. Okay, so we need to bear that in mind. So the key words in this statement is the theory itself, which says Bronsted-Lowry. Now let's look at the second multiple choice question. Consider the equation below. We are given a reaction between carbonic acid and water to give us hydrogen carbonate ion and hydronium ion. So the question says the Bronsted-Lowry bases are, right, so I'm going to underline Bronsted-Lowry. Now, this is about the theory of acids and bases. Now, we need to remind ourselves once again, what are Bronsted-Lowry bases? These are proton acceptors. So once we know that, we are able to apply that knowledge. Now, we are saying bases are proton acceptors, right? So if a base is a proton acceptor, let's consider this reaction. Let's identify the bases with respect to this description in terms of the Bronsted-Lowry theory. So if you look at carbonic acid, it acts as an acid because it donates one of its hydrogen atoms to give us that, okay? So this is an acid, right? Meaning that, because this is an acid-base reaction, meaning that water acts as a base. Why? Because it accepts a proton, okay? So water acts as a base. So when water accepts, it gives us the hydronium ion, right? So if water is a base, it means that the hydronium ion becomes an acid, right? It means then in the reverse reaction, the hydrogen carbonate ion is a base. Now the question demanded that we identify two bases, a pair of bases in this reaction. So what do we have? We've got water as well as the hydrogen carbonate ion. So based on that, we can say D is the correct answer. But how did we arrive at that? We first try to understand in terms of the theory which substances are proton donors and which ones are proton acceptors. Right. Let's look at the next one, which says which one of the following pairs of reactants, right, will produce salt, water, and carbon dioxide. This takes us back to the types of reactions, right? Now, any acid-base reaction produces salt and water, okay? So the formation or the production of salt, has a wide range of reactions. So in this case, the question specifically wants us to identify a pair of reactants that are going to react to give us salt, water, as well as carbon dioxide, right? So we're going to interrogate each one of them and see which one gives us salt, water, and carbon dioxide. Now, if you look at reaction A, first of all, for us to get carbon dioxide, one of the reactants must have carbon and oxygen. But then if you look at the reaction between zinc and sulfuric acid, it's a typical reaction between a metal and an acid. This gives us salt and water. So there is no way we are going to get a gas in this case. So we're looking also for a gas-forming type of a reaction. Now, if you go to option B, it talks about a base and an acid. So this is going to give us a salt and water again, right? This will give us salt and water. Still, it doesn't give us what? Carbon dioxide. So we'll eliminate that option, right? Now, if you look at the remaining two options, the reaction between a metal oxide and a sulfuric acid, or an acid for that matter, there is no way we can get carbon dioxide in this case, right? So we'll remove that option as well, right? And then also, if you look at the remaining option, which most likely is the correct answer, this is a metal carbonate, right? That's a metal carbonate which reacts with an acid. Okay, this is definitely going to give us what? A salt plus water, as well as carbon dioxide, because that's what distinguishes it from other reactants in the given options. So this is a typical gas-forming reaction, if you can come to think of it. Then this says to us that D is our correct option. So these are some of the few examples that we've used, but the main thing that we want to take home from these multiple choice is the technique, the approach in terms of responding to this type of question. So knowing the concept involved, highlighting the keywords in the question or in the statement, it will also serve as a guide in terms of eliminating the distractors and as well as coming up with the option that is correct. So it's not a typical way of shooting in the dark and taking a wild guess. So you need to apply the knowledge that you have in trying to identify the most correct option. That said, we'll take a short break for now. When we come back, we'll look at more type of reactions in terms of revising acids and bases. Let's take a short breather for now.